So welcome back again guys to my YouTube channel. So in today's video, I will be discussing a demo video that includes SymPy in module in Colab, Google Colab. So our teacher requests us to input calculus related problems into Python program, syntax code. Um, so the equations that are given are about limits and derivatives. So I will be discussing to you all how to input and output specific limit of a function given the value of x. So if the given problem or equation is if x approaches to 1, if f of x is x squared minus 2x raised to 2 plus x over x raised to 2 minus 1, if the limit approaches to 1. So if we run this code, the equation pops up as x approaches to positive 1. So this is the problem, this is the equation. So if the x approaches to 1, you, by the way, the limit is on capital letter L. It will input the equation. If the limit is lowercase l in the limit, it will give the specific answer as x approaches to 1. So let's run this code. So x is 0, the limit is 0 as x approaches to 1. So that's the first problem, and problem A plus 1. So, and note that you need this kind of input so that you could import the module of SymPy. From SymPy, import what do you call this? Asterisk. From SymPy, import asterisk. So initiate underscore printing dash. So moving on to the problem B. So let's run this code so that we can see the equation. So if the limit approaches to positive 3, if f of x is x cubed minus 9x over x raised to 4 minus 3x squared minus x plus 3. So if that's our equation, so if x approaches to positive 3, so lowercase l, so that we can find the limit of this equation. So let's run this. So 9 over 13. So that's the limit of this equation. So moving forward to this InClass activity 2, we will solve for the derivatives. So I've chosen 2. Problem number 9, which is the derivatives. So let's run this code. The derivatives of y dash x. You can see the equation. So this is the problem. If we don't type this, so we'll just have e raised to 4 log times 2x plus 1. Log is in here, or log, shortcut or other term in Python. So if we put derivative y dash x, so we could have the derivative of this function. So if we want to get the derivative of this function or equation, we'll put y here, dash y, diff y, dash y, so that we could tell the system to get the derivative of this equation. So let's run this. So we get 2e raised to 4 over 2x plus 1. So that's our answer. And the last equation from this activity that I've chosen from the set of questions or equations given to us by our teacher. So same as the last problem, we do have this from SymPy import asterisk, that we could import the equation and calculation from the given module in Google Colab. So initiate underscore printing dash. So my equation is number 24 from the given set of problems. So by the way, if we have a square root in the problem, we need to input sqrt so that we can square root this part and log this part. So let's run the code and see what find up. So this is the given equation. So square root of 4x minus 9 log times x raised to 4. So the derivative of this, we input derivative of y. Equation needs a to y. So let's run this code. So this is the output. 2 log times x raised to 4 over square root of 4x minus 9 plus 4 square root of 4x minus 9 over x. So that's our derivative from this function. So my final verdict from this InClass activity 2 is that calculus can be somewhat easy to solve in Python by just inputting the function and equation in a given set of problems and telling the system to output a given set of codes to have the answer, but it doesn't show you what is the process of achieving this set of answers right here. So yeah, it's kind of easy to input the code, but we don't know the process of obtaining the answer. It's just like plug and play. We plug the formula or code from the from SymPy import from the module in Colab, so that we could directly output the answer in a given function. So that's my learnings from this activity. So thank you, and like and subscribe. Thank you.